No problem. Well, thanks for coming. Good evening. My name's Nick Finch, and I'm CTO of a company called inmydata. I hope some of you probably remember us as Data PA. So we've been creating analytic solutions and business intelligence solutions for the Progress community for a good number of years now. And our latest offering, inmydata, is a cloud platform. And over the last 12, 18 months, we've been building a WebAssembly front end for our cloud platform. So today I want to talk to you about WebAssembly, why I think it's important, why lots of people in our industry think it's important, and more particularly why it matters to OpenEdge developers. So to begin with, just a quick history of web development, just to set the scene as to why WebAssembly is important, why we needed it. So I don't know, anyone in the audience recognize Netscape, that version, or who used it? Quite a few of us. So that particular version that we're looking at was released in 1995. This was the first version with JavaScript embedded inside it. So it was Netscape that first came up with JavaScript. They'd realized pretty quickly that we needed some functionality in web front ends, even if it was just to enable or disable buttons, that sort of thing. The first release took them 10 days to build and get out the door, so it was fairly simple, but it quickly gained a lot of ground. By 1996, Microsoft adopted it with Internet Explorer, and we all know how dominant Microsoft and IE became in the browser market, and so JavaScript really became part of the web and was pretty much accepted. If we run forward to 2008, that was the first release of Chrome from Google. That included their version 8 JavaScript engine, which was the first just-in-time compiler for JavaScript. And that marked a real step change in the performance of JavaScript and really kick-started people thinking about developing real applications in the web. And pretty soon after that, we had standards that were widely accepted, and JavaScript's just part of the web now, and we've all used it in our applications. So that's fine, and JavaScript's great for what it was meant for in the first place, scripting. But now we're all building pretty much any UI that you're building gets built in the web. And so we're all forced into using JavaScript for that. There's been a few attempts down the line of different companies trying to introduce different development techniques in the web or development platforms in the web. So some years ago we had things like Flash, Java, ActiveX, and they were largely controlled by single companies, so Macromedia or Adobe with Flash, Sun Microsystems with Java, Java plugins in your web applications, or ActiveX in IE with Microsoft. But because they were controlled by one entity, and really in terms of from the browser vendor's perspective, they're a black box that interacts with the web through an API. So they were really seen as a bit of a security risk. The browser vendors had no control over what happened inside those bits of technology, and so they fell out of favor, and now they're not supported in any of the web front ends that we've got. More recently, to try and help us sort of manage this massive JavaScript code that we're building up in the web, we've built frameworks like Angular, React, Backbone, Ember on the front end. And they're great, and they do actually really improve the productivity when you're building web front ends. But the real issue with them is that you end up writing your front end in JavaScript and your back end in a different language, whether that's ABL or C# or PHP or whatever it might be. And that constantly switching between two languages has a number of problems. We end up writing code twice, so your object model has to be defined in the ABL and in JavaScript, or in PHP and JavaScript. And you have to either have two sets of developers or developers that are fluent in switching between those two different languages. So another approach to try and solve that is Node.js. Look, if we're going to be stuck using JavaScript in the client, why not use it at the back end as well? And then we've got a single language and a single model throughout. And that's great, and it does work, but the issue is we're forcing everybody to develop everything in JavaScript. And over the last 25 years since it was first invented, there's been loads of innovation in all the different languages that we've developed. If we force everybody to develop everything in JavaScript, you're really going to stifle all of that innovation. So it's not ideal. And the real elephant in the room in terms of JavaScript is performance. It's an interpreted language, so we're sending the code itself in text format across the web, and then it's being interpreted on the client. So it's never going to get as fast as something that was natively compiled to the machine that it's running on. So more recently, there's been a couple of attempts to try and find a solution for that. Google are heavily invested in web development because of their Chrome OS, so the idea that everything's going to be developed for a web browser. So in 2008, they built Native Client, and the idea of Native Client was that you could take any C or C# code and you could compile it to Native Client. It would run in a separate executable natively on the machine where the browser was, and it would interact with the DOM and JavaScript through an API. In terms of security, they put it in a sandbox, so the executable didn't have carte blanche access to whatever was on the disk or the memory. It only had access to memory and local storage that was relating to that application. But actually, all the other browser vendors just saw it as another rerun of Flash and ActiveX. You've got a bit of technology controlled by one company. It's a black box from their perspective. And so they said, look, it's the same issue that we had with the security of those other technologies. So it never got adopted outside of Chrome. Out of Chrome OS. Around the same time, a guy, Alan Zakai, began work on a project to compile C, C++ to JavaScript. It's worth looking up some of his YouTube videos. He actually described it as a fun project to try and get C or C++ compiling to JavaScript, which is mind-boggling from my perspective. By 2011, he was working for Mozilla, and Mozilla adopted the platform that he was building. It was called Emscripton. By 2013, they'd realized that trying to get C and C++ to compile to natural JavaScript was really difficult. So they came up with SMJS, which was an optimizable low-level subset of Java, and they'd added some mass functions into JavaScript to allow them to do that. There's a couple of problems that still this didn't overcome. First of all, you're still compiling to JavaScript. So although you could take pretty much any C or C++, compile it to JavaScript and run it, it would never give you the same performance as if you compiled it to the native executable for the platform itself. And also it's a hack and it's untidy. So C and C++ are strongly typed languages, JavaScript isn't. So they had to do all sorts of backward somersaults and all sorts of hacks to try and get to shoehorn that type specificity into JavaScript. Around the same time, both teams realized that really to get something adopted by everybody in the community, they really needed to work together. So by 2013, both these teams began to meet and collaborate together. They were meeting for lunch and dinner. And by 2014, they'd come up with the concept of a virtual machine running inside the browser, executing bytecode. By 2015, they publicly announced WebAssembly, and then things moved pretty quickly. Only 2 years later, it was widely supported by all major browsers, and just a year later, Native Client and SMJS were retired. Emscripton still exists, but if you compile your C, C++ with Emscripton now, it compiles to WebAssembly. So where are we today? Well, WebAssembly is supported by all major browsers and by Node.js, and that support from Node.js is important because it means you can run WebAssembly on IoT devices and all sorts of different platforms. It's efficient and fast. I've got a couple of quick demonstrations for you. I'll open. So this website's called Wasm Fiddle. If anybody's ever used JS Fiddle or .NET Fiddle, it just allows you to put a little bit of code into the browser. See if I can make that a bit bigger and compile it. So I've got a bit of C# code here, and it's dead simple. I've just got, if I add another function in there, I've just got two very simple functions. The top one called main just returns an integer of 42. The bottom one called 3 just returns an integer of 3. So two very simple C functions. I can compile them. So there's two different formats for WebAssembly. There's WAT, which is WebAssembly text, and that's a readable format that you can actually see what somebody's compiled. And then there's WASM, which is the binary format of it, and that's actually what we usually distribute. If we ignore the first 3 lines of code down here, we've got two function definitions, much like a forward function declaration in progress, exactly the same sort of idea. And that's important because it means that WebAssembly can be streamed to the client. So you can start executing it as soon as you start getting the code. And if you come across a function call and you don't have the implementation yet, it just waits until the implementation comes down and then carries on running. So very efficient in terms of how it executes this code. But also, if we convert it to the binary format, obviously it's not going to mean a great deal, but that's just 100 bytes for that, or 100 numbers for those two functions. So it's really efficient in terms of the size of the code that we're distributing, much, much more efficient than JavaScript was. More importantly is the execution speed. So this is just a little demonstration where I can run this bit of code and it's generating these avatars and then animating them, and I've got 100 of them here. Now initially it's just running in JavaScript and you can see it's quite jerky. We can actually see these things moving, but if we run exactly the same code but this time running it as WebAssembly, suddenly you can see it's very smooth. So in terms of what we can do with WebAssembly, that performance gives us a load of opportunities for things that we can now do in our browsers that we wouldn't have thought of doing beforehand. So who's on board? There's a not-for-profit organisation called the Bytecode Alliance. If I just read out that second paragraph, so the Bytecode Alliance is committed to establishing a capable, secure platform that allows application developers and service providers to confidently run untrusted code on any infrastructure for any operating system or device, leveraging decades of experience doing so inside web browsers. So the idea is we're taking everything we've learned over the many years of web development and trying to take those lessons into a wider application development environment. And companies that are part of this Bytecode Alliance, well, Google, we know they were part of actually developing WebAssembly in the first place, and they're well invested in web technologies with Chrome OS. So they're on board. Microsoft have invested huge amounts of money in Blazor. So Blazor allows you to take .NET code and compile it to WebAssembly. You can already build your web apps using WebAssembly, and Microsoft have already stated that they think the future of desktop application development will be Blazor as well, so compiling things to WebAssembly for your desktop applications. Mozilla, obviously, we talked about those guys earlier. They were part of the actual development of WebAssembly. And then you've got companies like Intel and ARM, so hardware developers who are also invested making sure WebAssembly runs quickly and efficiently on all your different devices. And then there's lots of web platform developers like Shopify as well, who are also on board. So a really broad range of companies that are behind WebAssembly and really see it as the future of application development. So just some examples of what you can do with WebAssembly now. Sure everybody remembers Google Earth. It used to be an application you would download and run an executable locally on your site, locally on your machine. Now it's just a web app, so it downloads Blazor, and you've got all of the functionality that we used to have with Google Earth, but this time running in your browser. A more useful example here, perhaps, Modify, so a better way to convert videos. So this is interesting because you convert videos within your browser without uploading files anywhere. Okay, so if you want to convert from MPEG to AVI or whatever, it used to be that you would go to a site, you'd upload your video to some server somewhere, it would convert it and send it back to you. whereas now I'm doing it just in my browser. There's a couple of great advantages to that. Number one, I don't have to send my file anywhere, so nobody can copy it, or I don't have to worry about the IP of it. But more importantly, for the guys who host the website, a website doesn't do anything. It's just a simple website. Actually, when I convert the files, I do it locally on my PC. So it's much easier for these guys to provide that service and much cheaper for them to do it. This one here is a fantastic example. So this is AI voice recognition in the browser. So if I, hey barista, shot espresso. There you go. So if you're wanting to develop an application and you want to put voice recognition in it, you can have that. And again, it's not sending a recording of the voice to the server. That's all just happening in my browser, running it there. And then last but not least, inmydata.com. So this is our web application, our analytics application. And if I log in, it's a great example of we were able to push so much more of the functionality, building analytics, building dashboards, rendering dashboards. We pushed a lot of the code into the browser. So that rather than doing the work on the back end, we're doing most of the work on the in the browser itself. So it just makes it more efficient from our perspective in terms of hosting it, but also from the customer's perspective when they're using it in terms of how quickly it reacts. There's many fewer round trips to the server to actually render things like these dashboards, and if I change any of the filters, again, they're all done on the client. So just a few words on our experience. It's getting on for 18 months that we've been working with WebAssembly. We don't do a lot of development in OpenEdge anymore. Most of our development is in .NET. So we were taking what was an ASP.NET SPA application using Backbone. If that's gobbledygook to you, it basically C# on the back end, JavaScript on the front end, and we use Backbone as the framework to manage all of that JavaScript code. So we were porting that. We started just trying to do a couple of new small projects, and we've now ended up trying to port the whole front end to Blazor. It was built using Microsoft's implementation of WebAssembly, which is Blazor, running .NET 5 in the browser. We actually found Blazor had an awful lot of similarities to WebSpeed. So if any of you ever used WebSpeed and you remember SpeedScript, you'll recognize the sort of idea behind what we're looking at here. So I've got HTML code, I've got a heading with counter on it, and then I've got a paragraph, and then we've got escape characters and variables that are my C# variables. They would have been our ABL variables in WebSpeed. And I'm mentioning, or I'm calling functions when you press the button, and then we've got a code section underneath, which is actually executing that function. The big difference here is that C# code runs in the browser, whereas in WebAssembly, your ABL would have been compiled and run on the server, and you would have had round trips every time you click the button. Here, this all happens in the browser, so it's much quicker. From our perspective, sharing code between the client and server was really important. We were creating our object model in C# on the server. We used to have to create it again in JavaScript on the client. Now we could create it once and use it in both places. So we were writing much less code, and we were using one language throughout, which made life really easy for us in terms of developing the front and back end. When we first started using it, Blazor was only, I think, two weeks old when we first started using it. We found debugging it in the browser or in the client really difficult. It was just flaky, didn't work. But actually, credit to Microsoft, they got it working pretty quickly. And if I just go back, you'll notice here, this is Edge. It would work exactly the same in Chrome. I'm debugging something, so I put a breakpoint somewhere in my code in the browser, and then I'm debugging it. But when we look at it, instead of JavaScript in my DevTools console, Now I've actually got my C# code sitting in my DevTools console. And over on the right-hand side, you can see I've got a watch window open. This is one of the objects. It contains the definition for the objects on the dashboard. And you can see I can see all the properties. So actually now it's great. You can just debug it really easily in the browser, and it's like any other development environment. So all that's great for us as .NET developers, but obviously this is a progress conference, so how does that relate to you guys as progress developers? Well, interestingly, with the release of 12.4, OpenClient now supports .NET Core 5, and that's really the prerequisite we need to be able to use it in Blazor, to be able to compile it and use an OpenClient proxy in the web. So I thought, great, let's have a go, see if we can use that. If you've never used OpenClient before, it basically allows you to take an API that would be a bunch of .ps or any progress code that exposes an API and compile it to a bunch of objects for either .NET or for Java. So it's a really easy way of an API. And it builds in all the connectivity to the app server for you, so you don't have to code any of that sort of stuff. So if I jump in, so the first thing we did, okay, let's just create a very simple procedure, progress procedure that's just going to drag all of the customers out the the Sports 2000 database, stick them in a data set, and that's defined as an output parameter. So couldn't be more simple, just a few lines of code, and then we use Progress's proxy generator. We just add in the procedure that we want to expose to .NET, and you just do file generate, and that generates your .NET components that you can then use in a .NET project. So here I've got my .NET project, and the first thing that I wanted to do was create a class that just wrapped up the proxy so that I could use it quite easily in my code. And I created a connect method. So there's not a lot in here, it's dead simple. We pass in a URL, a user ID, a password, app server info, everything I need to connect to my app server. I create a progress connection object. I set the session model for it, and then I try and create one of my proxy objects using that connection object. And that's what actually tries to connect to our Pacific app server at the back end. I then created a very simple page just to try that out. So at the top, I just say if we're connected, then I'm going to shout about it. Happy days, we're connected. We've got OpenClient working in the web. Otherwise, if it's not, I'm just going to display whatever errors there are. And down the bottom, you can see us trying to connect when you press the button. And again, it's dead simple. I just create my OpenClient object and then call the connect method on it. So just a few lines of code, and we can test whether our app server connects. At this point, we're thinking great because Blazor's recognized all of my objects. I've managed to compile it all. It's all compiled. I've put it up to the browser. It's accepted it all. So I've got bits of progress .NET code actually running in my browser. We try and connect, and we do get a connection error. If any of you have ever used OpenClient, you'll recognize that. It's basically the connection error you get when you have got your connection parameters wrong. So at this point, we thought, fantastic, we're there, it's working. But actually, when we dig down into it, the problem is something's not supported. So the Progress OpenClient technology is using, and when we dug into it, the issue is that it's using Web Client, which is an older .NET implementation of the HTTP protocol, and that's not supported in Blazor. We should be using HTTP client instead. So unfortunately, we can't use OpenClient at the moment, which is a real shame. But actually, it should be a really easy fix for Progress. So we have put a note on Progress's ideas forum, and hopefully that's something that can be fixed fairly quickly, and we'll be able to create OpenClient interfaces to WebAssembly front ends. So if we can't do that, well, we could quite easily fall back to REST APIs, a web API, so there's absolutely no reason why our browser can't connect directly to our PaaS OE and talk to progress code we've got running at the back end. I haven't developed in Progress for probably about 12 years. The last time I actually did any real development in Progress in anger. But creating these things was dead simple. It took me, I don't know, maybe 10, 15 minutes to create these. So the first thing you need to do is you need to create your REST API. Progress gives you a wizard to create that stuff. You need to create your web handlers. That's the actual code that's going to drag the data out your database or put your data back in. Again, there's a wizard that gives you a framework, and you just have to populate the details of what you're dragging out the database or putting back in. And then you need an ABL service at the top end. Again, there's a dead simple wizard to allow you to do that. So if I just run through in a couple of minutes what we had to do to create those things. So up here in the top left, that's my REST API project. So to create that, we just do file new, OpenEdge project. It's a server project. We're using the web transport, press finish, that's it. Takes 2 minutes. So that created my project. I then need to create my web handlers within the project. Again, that's dead simple. Right click on your project, just go to new web handler, give it a name. So I was just dragging out the employees from the database. Say what method stubs you want. I only use get. It's a simple example, but actually you probably want everything else in there as well. And then press finish, and that gives you a stub. So it gives you all of the definitions and all of this gubbins to actually send the data backwards and forwards, which I was completely unfamiliar with. But the only code I actually had to add in was these 5 or 6 lines to actually drag the data out and send it back. So again, really easy to do that. And then to add the service on top, again, just do file new, ABL service, give it a name, and then say what you want to expose. So I wanted to expose my employee handler, give it a name. So this is what's going to be in the URL to call it, and press finish. Again, so took very little time at all. Having done all that, I've then got a URL I could call, and it gives me, this is just a JSON with all the employees in. So again, by this point, and this is me coming at it cold, I'd created all of this in about half an hour. So it didn't take very long at all, very easy to do. Obviously, in a live environment, you want to stick some security around this and everything else. So it's going to take a little bit longer, but not complex, not difficult to do. And then we want to consume that within our ABL, our Blazor front end. So I created another client object, much like the one that we created for OpenClient, but this one's even simpler because it's just using HTTP transport. It's just calling that web page. So I created an HTTP client. I pass in a base address, which is the URL to whatever it is I'm connecting to. And then I've got a method to get employees and a method to get my departments. And I just call, if I scroll along, I just call employee or departments, which just sticks that on the end of the URL and makes that call to the back end. I defined some objects to receive my employees, so a model. Because I'm not using OpenClient, I don't have a strongly typed data set coming back, so I define my own strongly typed objects to receive the data into, and it just converts. C# will quite easily convert what you get from the REST API into a C# object. Just define a property for every, yes?
You wrote that manually, or you generated it?
I did a list of fields, and then just, I did it in Excel actually, but So yeah, but you need to effectively write it manually in some way, but just so that we could actually see some functionality happening in the browser, some C# code happening in the browser, I added a few extra properties to my object. So full name, I just add the first name and last name together. Total days left, I just add vacation days and sick days, and I worked out the age from the date of birth, just so that we could see something happening. And then to actually create a page to consume that. So I think it's quite small over on the left-hand side, but this is slightly different from having everything in one page where you've got your code and your markup in one page. You can split it out if you want to. And we found in reality, when these things start getting quite big, it's much tidier if you do split them out into different sections. So I've got two files. I've got my code file, and there's pretty much nothing in this. I just create one of my client objects, and I call the two methods that we created to get my departments and my employees. So again, there's only really 2 lines that are doing anything in there. And then in the markup itself, at the top, I'm going to say, if we've got an error message, I'll display the error message. Something's gone wrong, we couldn't read it. Otherwise, if employees is nothing, well, there's no error, we don't have any employees left, we must just be loading the page. So I'm just displaying loading. Otherwise, I'm going to say there are however many employees. I've got a drop-down list here. You can see I've just got a little for each going through all of the departments to populate my drop-down list in the web. And then underneath that, I've got a grid just to display my employees. I wanted to use the Telerik controls. Thought that would be a good way of demoing Progress's controls, but unfortunately the Telerik controls need a ASP.NET backend for some reason. I'm not quite sure why. And I wanted to host this on my Pacific app server, so I didn't want anything that needed to be on the back end. I just wanted it to be a pure client application. So all of that, again, didn't take very long. You know, there's in total, I've probably got 40 lines of code to create all of that in my client application. And this is what we end up with. So once it's loaded, I can see there were 55 employees. I can select a particular department if I want. I can sort by age. You see the oldest is 74, the youngest is 54, pretty much like us lot, I guess. And you can sort it. I could put in a position, maybe admin in there, and we can filter it. So a whole load of functionality that's been really quick to put together, but also it's efficient code as well. It's reducing the number of round trips. There's a lot of functionality that's happening just purely on the client. The only call to the server was to get that list of employees, that's it. There's no other calls going on. Yeah?
How about paging or big data sets?
Yeah, I mean that control, yeah, that grid pages by default. So it will just, if I go back to it, yeah, it was just I think in the code there's a property there to say page size. There we go, that line. So you just say how big you want the page. And those Radson controls are free. They're open source, so don't cost anything. And as I said, you know, our Pacific app server is a web browser. It's Tomcat. It's a web browser. So Blazor's just static files. So all I did was I compiled my Blazor app, stuck it in the root directory. I had to tweak the security a little bit just because the Blazor files have a different extension to them, so I needed to make sure Tomcat let that extension through. But really easy to actually then host that, and as Peter was describing earlier, it's really easy to take an instance of your Pacific app server and just stick it somewhere else. So really easy to deploy that both on the server, but from the client's perspective, there's no deployment at all. So given, you know, I was talking about our experience of using WebAssembly, and a lot of the advantages for us were the fact that we were using the same code on the client and the server. That's not what we have in an OpenEdge environment. So given that, why should you consider WebAssembly today? Why should you spend any time thinking about it? Well, there's a number of advantages. Scalability, so because you can do a lot more on the client, your applications are much more scalable. If you think about, say, generating PDF reports, there are components that you can download to generate PDFs in the browser. So you could create your reports and run your reports in the browser, generate the PDF in the browser. So if you've got 100 people running reports first thing in the morning, you've not got a server that's trying to generate 100 PDF documents. You're just doing that all that work in the browser. Along the same line is performance. There's many fewer round trips between the client and the server. So your whole application becomes much quicker, much slicker. We've just talked about deployment, the fact that we could stick it all on our Pacific app server. So really easy to deploy. And then finally, security. And I think this is the key. This is why WebAssembly is something we should all take note of and all think about. If you think back to that description from the Bytecode Alliance, it was about running untrusted code on any platform, anywhere. So at the moment, if you want the same scalability and performance, that we would get with WebAssembly, the only way to do that is to create an executable client and install that on the client machine. And lots of us do that. That's a tried and tested way of doing things, whether we're using .NET for GUI or a GUI front end or a C# front end, whatever it is. But if you're installing an application on your customers' computers, your customers are effectively handing you the keys to their operating system. You have pretty much free access to write to anywhere on disk, any portion of memory. That's fine when it's the relationship between you and your customers, because you don't have any malicious intent. You are there to help your customers, and there's a trust relationship between the two of you. But these days, pretty much all of us will use lots of other packages within the applications we build, whether that's from package libraries like npm or NuGet, or whether it's just components that you're adding into your applications. And every single one of those packages also has the keys to the operating system that you're installing them on. And there's been a number of cases, an increasing number of cases, where people have done things like they'll create a package, they'll put it up to a library like npm or NuGet, and it's a useful package, it's got no malicious code in it, and then some months down the line, they update that package and they put some malicious code in it. And anyone who's used that package then updates their own application, and that malicious code then gets distributed with our application. And there was one case in particular where there was millions of dollars of bitcoins that were actually stolen through exactly that kind of hack. So the days of people trusting us to install applications on their desktop are probably numbered. It's probably going to go the same way that Flash and ActiveX and Java in the browser went. Given that we now have an alternative, we can use all of those packages in whatever code we're using in WebAssembly. We can download those packages, we can still use them. NuGet's full of anything that's in .NET you can use. In WebAssembly, you can compile 40 different languages to WebAssembly, but it runs within a sandbox. So whatever is being executed can only have access to a portion of the disk and a portion of memory that relates to that application itself. So it will be seen as safe in the way that we now don't let anybody install anything in a browser the way that we used to. So what could we do in the future? Well, first of all, it'd be great if OpenClient worked in Blazor, so that we could quickly and easily create these APIs. REST APIs are great, but we all know developing a big application, eventually you're going to want to do something that doesn't really fit into that framework. So OpenClient would give us a great way of doing that. This second point, I have to hold my hands up here and say this is absolute conjecture from my perspective, okay? But I think this is what Progress should be doing, okay? Allowing us to compile ABL to WebAssembly. Now it might sound a crazy idea. I have actually put it on the ideas forum. Matt Baker came back to me and said, sounds like a great idea, but it's a multi-year, huge problem. I've actually pushed back on that. I think if you look at it in detail now, and Obviously, this is somebody talking who's had no input into the development of Progress, just somebody who's used it for a while. But I think the AVM is underpinned by C. It was written in C, so you could actually probably compile large portions of it to C already. There's also a tight integration between .NET and the ABL already, and the whole of .NET is now available in WebAssembly. So there may well be other big reasons why we can't do this, and there are certainly things that you can do in the ABL that you would never be able to do in WebAssembly, like connecting to your database for a start. But that's not what we want to do. We would want something like WebAssembly, like web speed, but where the ABL was actually being run in the client. And I think if Progress could do that, it might well open up OpenEdge to a whole new audience and really give it some momentum. So any questions? There's a plug for our software at the top there, a shameless plug for our software. If you're interested, have a look at inmydata.com. But any questions? Vim?
Also runs on mobile phone browsers?
Yep, runs on anything a web page would run on. Yeah, yeah. Yes.
Is there any minimum version of software required, or is it just PASOE?
As long as you've got PASOE, yes, yeah. Yes, yeah, you could certainly run it with 11.
REST also works with 11.2 and the REST adapter, so that goes pretty far back.
Yeah.
So that would not be web handler, that would be the classic REST adapter, but REST is REST.
Yeah. I mean,
It's actually true. Version 9.
that's it. If you can expose a web API, you could consume it from Blazor, you know, so, from WebAssembly.
So Nick, did you have a reaction from product management on the open client issue? I actually would call it a bug and not a feature request. But,
yeah, I haven't had a response yet, no.
Because it was logged as a feature request and not as a bug.
Yeah. But if you'd like to use it, I mean, I would recommend, you know, I'd hope, go and have a look, see if you can find my post up on the ideas forum and just vote it. You know, hopefully Progress will fix that for us pretty quickly.
So I have another question here. So how easy was it to deploy the WebAssembly application, and did you run into any issues?
Yeah, it was. I mean, to deploy it, you just stick it on a web server, and people download it. We did come across one issue in that when .NET is compiled to WebAssembly, it compiles to DLLs, and we had one customer whose firewall were picking up those DLLs and not letting them through. They're not actually, but because they're named the same as the standard .NET DLLs, it said, no, this is a virus or something, but they're not. They're just WebAssembly. But you can rename them now when you compile your Blazor. So there's and I think in .NET 6 they've stopped that way of compiling it.
Will the source code be available for your demos?
Yeah, I'll stick it on. Where's the best place to stick it, Mike? Well, I'll stick it on our website if you want, and yeah, you can download it from there. Yeah.
You could also create a Git account for the conference and have different info for the presentation.
That's a great idea.
Whatever you prefer.
Yeah, yeah, that'd be great. Yeah. Great. Well, thank you very much.